In this clip we're going to explore how Pythagoras can be used in relation to isosceles triangles. Now we know, don't we, an isosceles triangle simply has two equal sides and two opposite equal angles. Now the type of question we might get asked is, can you find the area of this isosceles triangle? Now obviously the most important thing is we've got to know what the formula is for an area of a triangle, which we know is a half times the base times the height, or base times the height divided by 2. Now one of the challenges that we have to be careful about here and is to think, oh well, there's the height, so it's half the base times the height. Now what's the problem with that? Well, the problem is that that's the slanting height. This formula applies to what's called the perpendicular height. In other words, it's that dimension there. Okay, now you can start to see immediately some bells will be ringing, thinking, oh, we've got something to do here with isosceles. Why? With Pythagoras. Why? Because that's got to be a right angle triangle. So before I can calculate the area of this isosceles triangle, I need to know what the value of x is, don't I? Okay, so let's just have a think then. So to find that, let's just sort of select that bit of triangle. We know that that's 10. We know that that's 6. We're looking to find side x. So we know from our Pythagoras theorem, let's just keep that as, so x squared equals 10 squared, take away 6 squared, so x squared equals 100, take away 36, x squared equals 64. The square root of 64 means that x is equal to 8. So we can go back and we can put that information into our isosceles triangle. Well, now we've got to think, right, okay, we've now got to work out the area of this triangle. So the area of the triangle is half the base, so half the base is 6 multiplied by the perpendicular height, so, which is 8. So half the base times the height will give us an area of 48 centimetres squared. And that's it.